Welcome you all to the new section in which we are going to learn about the forced vibration. So in forced, vibration, so forced vibration. So in case of forced vibration, the reason behind the reason the reason behind the motion reason behind the motion is present. So let's study about the new term that is called external excitation. So let's learn about it. So external excitation. So this is the harmonic case, which is dynamic in nature. So this is the harmonic case, which is dynamic in nature. So the arrangement looks like something like this thing. The arrangement will consist of this spring and the damper which is attached to some mass of block mass m, and we are this mass is subjected to some force, that is F naught sine omega t. So here F naught, so F equal to F naught sine omega t, that is the external force. So in this case here F naught is the amplitude of force, and here omega is the frequency of force. Here omega is the frequency of force. So let's plot the free body diagram for this case. So when we are going to plot the free body diagram, so this is mass m, so which is subjected to F naught sine omega t. So in counter, in order to bring the mass to its initial position, there are three external force which are going to act counter to this force, that is inertial force Fi, spring force Fs, and the damping force, that is Fd. So let's write the equation of motion for this case. So let's begin by writing the equation of motion. So equation of motion in this case equal to Fi plus Fd plus Fs is equal to F naught sine omega t. So mx double dot plus cx dot plus kx is equal to F naught sine omega t. So let's take out mass m common. Then the left expression is x double dot c by m, x dot plus k by mx, which is equal to f naught by m sine omega t. So after further simplifying, we are going to get x double dot plus 2 zeta omega n x dot plus omega n square x is equal to f naught by m sine omega t. So the solution of x is here. So the solution of x x is equal to function of t. So x is equal to complementary function plus particular integral. So let's calculate complementary function first. So the complementary function is equal to x dot e power minus zeta omega n t dot sine omega dt plus phi 1. So particular integral for this case is equal to f naught by m sine omega t divided by d square plus 2 zeta omega n dot t plus omega n square. So let's further simplify this equation. So let's further simplify this equation, that is f naught by m sine omega t divided by omega n square minus omega square plus 2 zeta omega n d multiplied by omega n square minus omega square minus 2 zeta omega n d divided by omega n square minus omega square minus 2 zeta omega n d. So let's further solve it. We are going to get f naught by m in bracket omega n square minus omega square dot sine omega t minus 2 zeta omega n dot d sine omega t divided by omega n square minus omega square whole square minus 2 zeta omega n square whole square, sorry this is not square, d square. Now let's further move further simplifying this equation. Now let's further simplify this equation. We are going to get f naught by m omega n square minus omega square dot sine omega t minus 2 zeta omega n dot omega cos omega t divided by omega n square minus omega square whole square plus 2 zeta omega n dot omega whole square. So let omega n square minus omega square is equal to r sin r cos phi and 2 zeta omega dot omega n is equal to r sin phi. So we are going to get r square is equal to omega n square minus omega square whole square plus 2 zeta omega dot omega n whole square. So let's now the tan phi is equal to let's calculate first. Let me write this thing first. So the tan phi is equal to 2 zeta omega dot omega n divided by omega n square minus omega square. So the particular integral is equal to f naught by m r cos phi dot sin omega t minus r sin phi dot cos omega t divided by r square. So after further simplification, we are going to get f naught by m dot r sin omega t minus phi divided by r square. So let's calculate further. So the particular integral is equal to f naught by m dot sin omega t minus phi divided by under root of omega n square minus omega square whole square plus 2 zeta 2 zeta omega dot omega n square. So f naught by m dot sin omega t minus phi divided by omega n power 4 1 minus omega square divided by omega 1 minus omega n square whole square plus 2 zeta omega dot omega n square by omega n whole square. Now let's further simplify. So let's further simplify it. So after further simplifying, we are going to get f naught by m sin omega t minus phi divided by omega n square under root of 1 minus omega upon omega n square whole square plus 2 zeta omega by omega n whole square. So in order to simplify, we are going to take omega by omega n is equal to r. Here omega omega is the frequency of excitation and omega n is the natural undamped frequency. Natural undamped undamped frequency, and here R is the frequency ratio, so we call R as a frequency ratio. So after further simplifying, we are going to get the particular integral in the form of sort of further simplifying, we are going to get particular integral in the form of f naught by k dot sine omega t minus phi divided by under root of 1 minus r square whole square plus 2 zeta r whole square. So we can substitute this thing as this term as an a, so we can write the particular integral is equal to a dot sine omega t minus phi. So from this thing we can deduce that this equation is this equation, let me use this thing first. So we can say that pi is equal to a dot sine omega t minus phi. So this thing is harmonic in nature, having time period is equal to 2 pi by omega, and amplitude of the amplitude of particular integral is equal to a, and the frequency of the particular integral is the omega, that is the frequency of excitation, So so in the next lecture we are going to discuss about the equation of motion, and we will cover further more topics like magnification factor and all. So for now, thank you.